Let's work now with manipulations of Fisher projections and see what results after you do things such as rotations. So let's do one molecule here. And let's say I have this is only one chiral center. So oh, here I have one OH, H, and CH3. Let's do a quick determination of the absolute configuration at the center. And we are going to remember the convention. In Fisher, we have dashes on the vertical lines and wedges in the horizontal, right? So in doing that, next step was assigning absolute configuration is giving priorities to the group. So here you have for different constituent, highest priority is the OH. Then you are in between this carbon, which has, say, 3 bonds to oxygen, because we can redraw the carboxylic acid group as, let's do that explicitly just to remember that it will be this, meaning that you count at the carbon, there's 3 bonds to oxygens, 1, 2, 3. So obviously that has higher priority than a carbon that has 3 bonds to hydrogen. So that's priority 2, that's priority 3. 4 is a hydrogen, and now you follow those priorities, and you need to remember that the hydrogen is on the wedge, so not away from your view. So if you did here, 1, 2, 3, this rotation, you remember that it looks like R, but you're viewing that incorrectly, so it is S, the configuration of the carbon. So now what I want to do is I'm going to make a rotation here of 180 and see what is the result of that. So meaning that I'm going to put that right here below in my new drawing. And this time I'm going to simplify the group. This, I'm going to write CO2H. Remember, in doing that, I'm going to have the H now on the top. And see that, then I'm going to have CH3. So notice CH3, so CH3 is here, and H is here, right? So let's see what happened with the absolute configuration when you do 180-degree rotation. Again, my priorities are 1, 2, 3, and 4. You're viewing that incorrectly with the hydrogen towards you. And so you will do 1, 2, and 3 looks like R, but you're viewing incorrectly, so it is S. So we conclude that a 180-degree rotation on a Fisher projection, it just gives you another drawing of the same molecule, right? So now I'm going to do a different rotation. Say that I do from this structure, I'm going to do now a 90-degree rotation. So, in other words, I am going to say the metal is here, I'm going to put it here. And everything is going to be 180. So let's do that. We say that, again, 90, meaning CH3 is going to be here. This here, so I'm going to have OH here, then H, and that. Notice now in this drawing, the hydrogen is behind you. So let's see what happened with the absolute configuration when you did that. So again, I rotated 90, this go here, then the OH went here, H went here, and the carboxylic acid. So let's see what happened with the absolute configuration. Priority 1, priority 2, priority 3, right? And we go then 1, 2, 3. It is R. I'm viewing that correctly with a hydrogen on a dash. So notice then that this manipulation gave you the enantiomer. So pay attention to that. If you rotate a structure, if you wanted to have the hydrogen in the back, if you did that, you're going to get the enantiomer. And if you rotate them 180 degrees, you're getting the same compound, just a different drawing of the same molecule. In here, you can do also like you did with other drawings, you can do switches. Say that I do, let's see. I'm gonna try, let's try to do from this view. I'm trying to use the area as much as possible. So from this molecule, say that now I want to switch this to Y because I would like to have my hydrogen, which is the lowest priority group away from my view. So in doing so, I'm going to put the hydrogen there, the carboxylic acid here, and the other two remain the same. Remember, we did one switch. And we know one switch should give you the enantiomer, the opposite configuration. And we're going to check that right away. So we're going to say priority 1, priority 2, priority 3, and 4. Hydrogen is in the back. So we're going to go 1, 2, 3. That is R. So one switch did the opposite configuration. We learned that with other drawings before when we did wedge and dash. So these are things that we can do. Remember, that rotation 180 will not change. It's the same molecule. But if you do 90 degrees, such as the one that I did, now you get in the enantiomer. This is the enantiomer as well. The manipulation I did in this drawing was one switch, switching these two groups. And here what I did is a 90-degree rotation. So those are many things that you can do to manipulate structure to help you find absolute configurations.